So this question came up, and I think it's a really good example of why simplicity works. Marek asked, have you noticed that the implementation here is relying on the fact that numbers are, you know that the numbers only have a single character? And to that I reply, yes, absolutely, yes, hallelujah, thank you. Because this is something that should bother us. We implemented something in a very simple way, but now we don't like the code that we ended up with. This code isn't good enough, right? Because we took the most small step we could. Because it only handles single character numbers. But again, the first rule of TDD is you cannot write a code without a failing test. So if we really want to prove that this is wrong, we have to now write a test with numbers that have more than a single character. And the fact that we implemented it in such a simple way actually forced us to think about, hey, we forgot this test. This is an important test. If we'd started out with tests that only have multiple numbers, or we had implemented this in a very generic way like split, maybe we would have ended up with no test whatsoever that has numbers with multiple characters. And that's not a good thing. We want to have that test. That's an important test to have. And the one way I know to make me think about tests that I'm missing is by solving things in a very, very specific way, in a very incremental way, that forces me to say, aha, but you could have more than a single character. And now I'm forced to write a test that maybe I would never have thought about. That's another cool thing about the incrementality thing, that it forces us to think about tests we would never have thought about. So if I don't like this code, I can go ahead and write a test that says, what if I send in 10 and 20? Do I get back 30? 10 and 20 is the next logical numbers that have two characters. Not 10 and 11, but 10 and 20, because it feels simpler. It looks like, oh, 1 and 2, 10 and 20. I can see the difference between the tests. I can see the difference between the inputs. It makes sense. So I can go ahead and say, like this, sorry. Add two numbers bigger than one char. Now it begins to look a bit readable. Maybe like this, bigger than one character. Now I can say 10, 20, get back 30. If I run this, I got one failure. Expected 30, but was 1. That's good. I'm on my way. Now I can go ahead and say, okay, now I really don't know in my production code how big the number is. So I might as well use split. Okay? So before split, there is something else before it. And that something forced me to think about a test that I didn't think about before. So now I can say, okay, splitted equals numbers dot split. Let's just split it by a comma. Now, I'm going to take it in, especially for those new to Ruby, I'm going to take it in a very simplistic way. For Ruby folks, this might just be a one-liner, but I want to explain exactly how I'm doing this. So splitted will now contain an array of strings. Now I have to go through this array of strings and turn them into numbers, okay, or sum them up into numbers. There are several ways to do it. I'm going to show the way that, if you come from C#, it makes the most sense. But in Ruby, there are actually shorter ways to do it. But first of all, we have to learn the language. So maybe now I can say, okay, let's go through the array, and for each number, turn it into the integer version of that number. Integers equals numbers, and I'm going to use a method called map. And what map does is take a variable for each object in the array, for each element in the array, or you can just say just a number. Where is that character in this keyboard? Yeah. Just do this. Just don't rely on Sublime for now. So we'll call this some number. And for each number, we can transform it into an array that is the same size but contains different elements. For example, if the number is a string, we could just return the number to integer. And what we get back is an array that is mapped one-to-one to the current array of numbers. But instead of strings, it contains integers. Okay? Questions about this? I can actually have short forms of this. I don't have to do it in multiple lines. But I find that for me, this is still more readable. But we can also do it in curly braces in a single line and be done with it. Now, once I have the integers, I can actually go ahead and sum them up. Now, one way to do it is to say return the integers and then call a method called inject. Now, inject basically is a method that takes two parameters. It's a method that creates a delegate that has two parameters. The first parameter is the sum, or the result until now, and the second one is the current element that you're going through. So for each variable on this array, I'm going to get the current sum from the previous element and the current element, or the current result from the previous element. So for example, in the sum, I can go ahead and create a string concatenation of all the objects. I can go ahead and sum all the objects. So here, all I'm going to do is I'm going to return sum plus the element. Now, if I'm not mistaken, this should be enough to basically return all the integers summed up. What do you think? Will it work or not?
Not.
Why?
Because you have to type splitted equals. Oh, on the other side of the one line down, you have to type splitted dot.
Oh yeah.
And remove the extra end.
The extra what?
You have two ends a few lines down.
Oh yeah, I have an extra end. True. Let's see. Okay. Now, that took much more time than just running the tests, right? Although fixing it would have taken the same amount of time, I agree. But getting the feedback to know if it actually worked, that's the best way I know how. Yeah, you had a question?
What's the difference between inject and reduce? Because I would have used reducer.
I've never used reduce myself, so I don't know. But probably someone here knows.
They're aliases.
Sorry?
They're aliases of each other.
They're the same thing, basically. It's just one of them is nicer in specific situations and the other in different ones.
No, I think it's a preference. I think it's reduce is an alias of inject.
Yeah, in the documentation they are under the same name. Yeah. So I guess there is no difference.
Yeah.
Okay. Now we can go ahead and do things a bit even shorter, because in Ruby you can also do this: return integers dot inject, and then just give it the symbol to perform, like this. So for each object, call a method whose name is right after the colon. So call plus on each object and sum up the result of that object. So by default, it does everything I just did in the previous 3 lines. And once you get you get used to it, it actually simplifies your life a lot. because usually that's what you want. You just need to call a method, get back the result, and just add that up to the next one, to the next one, to the next one. So this one and the other one are the same thing. Yeah. Now, for now, you can just use this one, and then after you have the test passing, you can play around with the language and see if you can make it shorter and still readable. Okay? Because if we wanted to, we could also say map to I like this. We could also have done this. Return, splitted, map, and then again like this. To I, inject, plus. That would achieve the same result. Now, if you're new to Ruby, this looks like regular expressions. It's pretty horrible. But I'm not sure I would do it in real life. I would still try to make it readable. Or at least this is the approach that I know that a lot of Rubyists would use. But I'm more of the approach that readability is much more important than being smart. And I think this code could be too smart for its own good. Especially if at some point you want to make sure that the results are okay. But that's why you have unit tests. You can then later optimize or change whatever you want.
Does that work?
Of course.
I mean, that syntax.
Well, I can tell you from the test. We can
Yeah.
actually see.
Because for me it doesn't.
So let's see. Map, and you should get inject. Oh, I think it should work, but yeah, it seems to work. Okay? There's always one thing that you miss at some point. Then you get used to it. So questions. I wouldn't leave it that way. I would go to eventually having something that has a single responsibility and looks much more clean. Okay? For example, one of the cool things that I've seen people in my class do is that at some point you have custom delimiters. You can change the delimiters in the strings. But instead of parsing for all the possible delimiters, they just replaced the delimiters initially to always be comma. So the code is actually much simpler. So at the beginning, they just replace everything with comma, whatever is needed, and then just go ahead as if the code was as simple as before. So that's one way to think about it, is that that's one simple problem that you solve, and then you move on to the next one. So what I want you guys to do now is to split into pairs, hopefully, with people in the pair that at least one of you should know Ruby. And I want you to continue the TDD kata, the string calculator, as far away as you can. At least all the way to the half where it says if you're a beginner you can stop here. And if you get all the way to that point, you can go on after that. And I'm going to go around and try to help as much as possible. If you have any questions, I'll be happy to answer.
Do you remember which guys knows Ruby?
Sorry?
Do you remember which guys knows Ruby?
So in terms of people who know Ruby, most of the people who know Ruby are on this side, most of the people who don't know Ruby are on this side. So I would say every second person goes and sits on the other side, and every single person there sits on this side, and that should solve most of the problems.
Ruby